Hello dear student, today our topics is the lever, the lesson 4. You will see the man is lifting up an object. So first of all you have to know that what is lever. The lever is made up of a straight rigid object like a board or a bar which rotates around the fixed point. So it's actually a bar and it rotates. I think there is a fulcrum that it can rotates, or you can rotate these things, the bar, and to the fixed point, and there is a fixed point is this. So that's why you can lift up the heavy object. So this is the definition, and the parts of lever that's been in this lever, what is called this point, what is called this point, and what is called this point. We have to understand this thing. So parts of lever is a lever have a 6 very important parts. The one is the bar or beam. You see this is the bar or beam, you can say. And number 2 is the fulcrum or pivot or turning point. That means this is the fulcrum. This is called the fulcrum, and this is also called the pivot. And number 3 is the effort or force. This is the force you can apply it here. The force you can apply it here. And number 4 is the load. You can see the objects which is lifted. This is the load. And effort arm length. This means this is the effort arm length from this fulcrum, and the effort or the force. The force between distance between the force and the fulcrum is the effort, is the force length, force arm length. And the load between the distance between the load and the fulcrum is called the length, the load arm length. This is the parts of the lever. So first now we are going to discuss the definition. The bar or beam. The beam is simply a long plank. The long plank. This is called the plank. This is the beam, and it may be wood, metal, or any durable material. The beam is set on a fulcrum. You see these things. The beam is set on the fulcrum, the fixed point, a point on the bar creating a pivot. Okay, this is the beam definition. Okay, now come to the fulcrum. The pivot or a turning point, the fixed point where the beam or bar is to be set and rotated. The fulcrum you can set on the fixed point and it can be rotated. You can move, you can up, you can down, you can do anything. Okay, number 3, effort. Effort means the force you are applying. The force, effort applied to make the object or load move. If you apply the force here, the load automatically go up. So this is the force. And the load or weight, the object you are lifting, that means this is the very simple. This is the load, and every object has a weight. So the load is lifting when you apply the force. Okay, and number 5, the force arm length is very important. The force, you see the picture, this is the fulcrum, and there is a force, and there is a load. There is a very simple lever, and the point is that the force arm length or effort arm length, or you can say the input length, the distance between the fulcrum and the force is called the input arm length or the force arm length or arm force. You can say these things. The force and the related of the arm, the force and the force arm. So you can write a short form LI. There's been L for length, I for input. So input arm length or force arm length. And on the other side, the load and the fulcrum, the distance between the load and the fulcrum. It's a very simple definition. So this is called the load arm or output length. You can say that load and the load length or load arm. Okay, so these are the parts. So you have to know the parts of the lever. Okay, now we are going to discuss the very important things, the principle of lever. So here the very important law that, or formula you can say, that force into force arm is equal to weight into weight arm. So you can short form force into force arm and weight into weight arm, or you can say force into force arm, load into load arm. Is a very simple definition, because force is related the force arm, load into related the load arm. Okay, the formula can be expressed as a different way. You can write from this formula, you can write the division method, like the load by applied force is equal to force arm by load arm. Or you can say, you can flip these things. You can applied force by load is equal to load arm by force arm. Okay, so these are the formula of the principal lever. Is very important in mathematical calculation, or you can easily calculate any kind of things. If the three things are given, you can easily calculate it, the one things we will discuss later. Let's now come to the very important terms, is that the mechanical efficiency or mechanical advantage. The mechanical efficiency or mechanical advantage is that the machine can be used to find out how well the machine works and whether it can perform a particular job. It depends on applied force, force arm, load, load arm. The following formula is used. Very easy formula, just to weight by applied force. That's means the mechanical advantage, M for mechanical and A for advantage, is equal to weight. That's mean weight, W is the weight and applied force. So it is equal to also force arm by load arm, because you can see this is the force arm by load arm. That's mean is equal to load by applied force. You can write these things. So these are the formula. You have to remember these things, because in the mathematics of lever you have to calculate this thing. Okay, so come to the use of lever. When you use a lever, you move a smaller force a longer distance in order to lift a load a short distance. Example, a lever include a seesaw, pillars, crowbar and tweezer. So okay, so example of lever is the pillar. Pillar is I think like this, to cut or hold something else. Forceps, the tweezers, the forceps to grasp or hold any small object. Iron pry-bar, that's mean you can lift up the heavy objects to move heavy load. Seesaw, you know these things, the seesaw, a plank for children to play on, that is the balance in the middle on the raised bar with one end going up while the other goes down. And the crowbar to remove nail. Okay, so work out you can easily the questions. What is lever? You just go for definition, draw lever, practice the drawing lever. And what are the parts of lever? Explain with drawing. And what is the principle of law of lever? And write down the formula equations. Very simple questions. What is mechanical advantage? Give some example of lever and their uses. So here is the simple math. The applied math has given number 6. The applied force is 50 Newton and the load the 50 Newton. So here is the fulcrum, and the question has asked that find out the mechanical advantage or mechanical efficiency of lever. It's a very simple questions, and you just give the formula. The mechanical advantage is equal to, you can find out from the formula. Where is it? There, the mechanical advantage. You just give the formula, the weight divided by applied force. That's mean you write the formula, then you will give the weight, the applied force and the load, and you will find out the answer. And that's mean it will come maybe 1. So and number 7, the applied force of lever is 10 Newton. If the applied force is 10 Newton and the load is 100 Newton, so what will be the mechanical advantage? So very simple. You just give the formula and put the values, and you will get the answer. And here N stands for the Newton. The is a Newton is the unit of force, and it's Isaac Newton. It just discovered this force, and with his name, and the name of the unit has been given. And there is a fun and facts about the simple machine. There is just curiosity about the sentence information. The simple machines were first discovered and described by Greek philosopher Archimedes, the great scientist. And the Egyptians used the inclined plane to help build the pyramid, and using ramps you would have made getting the large stones to the top much easier. The Galileo Galilei was the first who worked out a working mathematical theory on how simple machines worked. The Galileo. Your bicycle makes use of nearly every kind of simple machine in order to make a more complex machine. The wheel and axle was an important invention in the history of mankind. It was first used around 5,000 years ago by the Sumerian. This is one kind of nations. So, okay. So that's all. That's all for this lecture of lever. And I hope you understand. Do you practice the questions? And okay, thank you.